Hello, everyone, and welcome back for the advanced version of factoring quadratics a equals 1. Don't worry, don't be scared. I'm here to walk you through this. All right, so we're going to go through three examples. Here we have the first example, x squared minus 7x plus 9, a equals 1, because there's 1 in front that we don't see. All right, so let's go through this process. If you don't know what we're doing in the basics of factoring quadratics, make sure you go back and watch the introduction and basic video for a equals 1. If you're kind of lost on some of the things I'm doing, it'll explain those things more in depth. So make sure you go back to that. All right, so again, when we're factoring a quadratic, a equals 1, we need to find two numbers that multiply to the last term, the constant c, which is 9, and add to the middle term, that b, which is negative 7. And we're going to get an answer that's two binomials where the first term is x. And the way I showed you to do this is by making a table. We're multiplying to a positive number, a positive 9, so we know both numbers are going to be the same sign. And since we're adding to a negative, we know they're both going to be negative. So I'm going to label that in my table. And then I'm going to start listing the factors of 9, things that multiply to positive 9. So that's a negative 1 and a negative 9, which adds a negative 10, which does not add to negative 7. 9's not even, so 2 doesn't multiply to 9, but 3 does, so we get negative 3, which adds a negative 6, and is not negative 7. And we have a problem. There's no more factors of 9. I exhausted all the options. When you're finding the factors of the number that multiply, on this side of the table or either side, you only have to go up to the square root of that number. So I don't have to try numbers past the square root of 9, so past 3. So that's it. There's none. This just can't be factored, which happens sometimes. When that happens, you would just label it as prime or not factorable. And that's perfectly okay. There's nothing we can do here. Not all quadratics can be factored, so we're done with this example. All right, so let's move on to another example that I have kind of hidden off to the side here that we'll copy and paste for us to work on. All right, so here we have x squared minus 4x minus 96. All right, so same idea. I'm finding numbers that multiply to a negative 96, add to a negative 4. I'm going to have my two sets of parentheses with my x, with my table. I am multiplying to a negative number, so that means the only way to do that with two numbers is if one is positive, one is negative. And I'm adding to a negative number, so that means if I'm adding to a negative when I have one of each, the bigger one has to be negative, or they would never add to a negative number. All right, so same process. I'm going to start with the factors of 96, starting with 1. So the smaller side's on the left, so plus 1 minus 96, which equals negative 95, right, when adding them together. Plus 1 plus negative 96 is negative 95. That's not negative 4, so I'm going to move on. It's even, so 2 is a factor, so plus 2 and negative 48. Add those together, and I get negative 46, which is not negative 4, so I move on. 3. If you don't know if it's a factor of 3, what you do is add the individual numbers. A 9 plus 6, which is 15. 15 is divisible by 3, so is 96. So 3, and that gives me a negative 32, which adds to a negative 29, which is not negative 4. 4 is also a factor. If you don't see that, it was divisible by 2, and the remaining factor is also divisible by 2, so it's definitely divisible by 4. So that's a plus 4 and a negative 24, which gives me negative 20. Also not negative 4, so I'm going to keep going. It does not end in a 5 or 0, so it's not divisible by 5. But since both 2 and 3 are a factor, 6 is also a factor. So plus 6, and that gives me negative 16 as the other factor, which adds to a negative 10, which is not negative 4. 7 is not a factor. 8, so 8 is a factor because when we used 4, it still had a factor of 2. So we know it definitely has 3 2's in there. So we have a plus 8 and a negative 12, which is negative 4, and exactly what we were looking for. So plus 8 and negative 12. All right, again, you only have to check the factors on the small side of the table until you get to the square root of the number. So the square root of 96 would be 9 something. So I wouldn't have to have checked past 9. All right, so there we go. We found it. We have our answer. And we'll move on to the next example. So here again, kind of put this off to the side. Let's take a look at the next example. So the first thing some of you might see is, a does not equal 1. And you're right, a does not equal 1. But something I've mentioned in the past and don't think I mentioned enough is the first step in factoring a quadratic is to look for a GCF. I've seen many people make the mistake of there's really not GCFs that many times. It's not as common as some other stuff. So you just forget about it. You get in that, the role of, oh, no GCF, just factor, 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 factor. Look for a GCF. In this case, there is a GCF. Right? We have to factor out that GCF in order to get the simplest answer. So we notice here that 2, 32, and 126 are all even numbers. So that means 2 is a factor of all of them. So 2 is my GCF. They don't all have an x, so x is not part of my GCF. And I'm going to factor that out. Again, if you don't know how to do this, there's 2 videos on GCFs. You can go back and watch that. So the 2 divided by 2 is just 1x squared. Negative 32 divided by 2 is negative 16. And a 126 divided by 2 is a plus 63. Okay? All right, so once I factor out that GCF, everything works the same. It's just you're only going to focus in on the quadratic inside the parentheses. And you just got to be careful. When I get my answer, I'm still going to have 2 quadratics with x in front as my answer, but I got to remember to put that GCF in front of those binomials. The 2 binomials where x is in the front. So make sure you do that. Don't forget about that too, or it will be wrong. All right, so then I'm going to go through the same process. I'm looking for things that multiply to 63, add to a negative 16. Since it's positive, they're both going to be the same sign. And since they're adding to a negative, they're both going to be negative. Starting with 1, negative 1, and negative 63 is negative 64, which is not 16. It's not even, so it's not divisible by 2. It is, however, divisible by 3. So negative 3 and negative 21, which is negative 24, which is not 16, or negative 16. 4 is not a factor since 2 wasn't. There's no way 4 could be. 5 is not, doesn't end in a 0. 5, 6 is not, because again, 2 is not a factor, so there's no way 6 could be. 7 is a factor, however, though, so negative 7 and negative 9, which adds to negative 16, which is what we're looking for. So we have negative 7 and negative 9. Doesn't matter what order I put them in. And that's our final answer.